Zealand Refining Company's Visitors Centre.
It is our pleasure to present this show to you, and we hope you find your visit both entertaining and informative.
Life is energy. Energy is life.
Much of our present lifestyle is dependent on energy in the form of petrochemical products. Marsden Point Refinery produces over 60% of New Zealand's petrol needs and more than 70% of its diesel needs. That's about 1.5 million tonnes of unleaded petrol and more than 1.5 million tonnes of diesel per year.
In addition, the refinery makes over 600,000 tonnes of fuel oil and bitumen and 900,000 tonnes of jet fuel and kerosene. This total production comes from over 5 million tonnes of crude oil and other feedstock.
Before 1964, New Zealand had to pay dearly for fully produced imported products. The decision was made to build a refinery that could at least supply some of the country's needs from high-quality crude oil.
Whangarei Harbour was chosen as the site because it has an excellent deep-water harbour, is close to the main North Island markets and has a low earthquake risk.
Set at the mouth of the spectacular harbour, the refinery is overlooked by the unusual rock forms of Mount Manaia. Local legend has it that the Māori chief Manaia had taken Hautatu's family captive, and after a battle between the two there was a great chase, and as Hautatu pursued them across the ridge, lightning struck, freezing them to the spot.
The Middle East crises of 1973 and 1979 and the consequent oil shocks caused a shortage of both crude oil and oil products. Prices skyrocketed. A barrel of crude oil rose from $3 to $30. The high price forced New Zealand to invoke carless days and power cuts to reduce oil consumption.
The government decided that a major refinery expansion was required to meet New Zealand's needs for the future. And in 1979, the go-ahead was given for design and construction. This massive construction project required the efforts of over 4,000 workers. Equipment and expertise came from all parts of the world.
The project was completed in 1986. And today, the expanded refinery occupies 120 hectares of land.
Given the natural beauty of its surroundings, the protection of the environment has always been a major consideration in the refinery's operation. The company strives to completely eliminate or minimise all forms of waste.
The refinery is so efficient that 95% of everything that arrives at the refinery is turned into a saleable product.
All gas and water discharged from the refinery is treated to remove contaminants and complies with all local and national specifications. Our environmental impact is so slight that the rare New Zealand dotterel nests not only in the sand dunes around the refinery, but also inside the refinery fences.
Refinery marine staff are actively involved in oil spill response training and regularly participate in exercises on local and national level.
We maintain an intense focus on health, safety and environmental performance.
This is driven by our commitment to quality and excellence and an approach of right first time, every time.
The company management systems meet international standards and are independently audited and certified.
The most prominent features of the plant are the flue and flare stacks, which are visible for many kilometres. The red and white flue stacks are the tallest at 120 metres, while the flare stack is 100 metres high.
The control room is the brains of the operation and is centred around a computer-based control system linked to over 8,000 instruments and sensors situated all around the plant. Our highly trained operational staff monitor and adjust the temperatures, pressures and flows involved in running the extremely complex oil refining processes.
The model in front of you is dressed in its night attire. The plant is working just as hard as it does in the daytime.
As the sun comes up, we can see the size and complexity of the plant. This model is accurate to virtually every valve and pipe and was used as a key reference tool when building the expansion.
The first part we will look at includes the original refinery. Completed in 1964, it produced petrol, diesel, bitumen and fuel oils. We still use this plant today, now upgraded and fully integrated into the expanded refinery.
The Marsden Point expansion project began in earnest in 1981. Many times larger than the original refinery, it took more than 5 years to build this huge and complex chemistry set.
The finished refinery had to be a world-class installation that could, within its heavy steel pipes and massive pressure vessels, turn the most basic crude into high-quality fuels. In 1986, after installing some 600 kilometres of piping, 50,000 valves, 550 kilometres of cable and 11,000 tonnes of structural steel, the expanded refinery came online, producing the fuels required by a growing nation.
The initial distillation of the crude is done in these 2 distillation units. Here, the crude is split into a number of groups or fractions. We use these later to make petrol, diesel and kerosene. The 2 distillers process around 13,000 tonnes of crude every day.
The high vacuum distillation unit highlighted here processes the heavy long residue left over from the 2 distillers to produce a waxy component that goes as feed to the hydrocracker.
From the bottom of the column, we pump the short residue to the butane de-asphalting unit. Here the oil is dissolved from the residue using liquid butane as a solvent. The oil is recovered from the butane and passes to the hydrocracker for further processing. We use the asphalt to make bitumen and fuel oil.
The heart of the refinery is the hydrocracker installation, consisting of 4 giant reactors. Built of special steel, the reactor walls are 190 millimetres thick and are designed to withstand the immense operational pressures of more than 120 times normal air pressure. The largest weighs 760 tonnes and stands 38 metres above the ground.
To hoist the reactors into position required the services of the world's largest mobile crane, doing its biggest ever lift.
The hydrocracker allows us to upgrade the heavy oil fractions into high-quality finished products and components. This cracking process requires large volumes of hydrogen gas, and this is supplied by the hydrogen manufacturing unit you see here.
This unit generates high-purity hydrogen from refinery gas, butane and steam. A byproduct of this process is carbon dioxide gas.
We sell this, it becomes the fizz in your soft drinks.
We feed the low-octane naphtha to the platformer unit, which reforms the molecules to produce high-octane components.
These pass to the benzene removal unit, where benzene levels are reduced. They are then blended into petrol.
Kerosene is fed to the desulfurization unit, where sulfur is removed as hydrogen sulfide gas. This purified kerosene becomes jet fuel. Gas oil components are fed to the gas oil desulfurization unit, where sulfur is also removed as hydrogen sulfide gas. The gas oils are blended into diesel. The hydrogen sulfide, a poisonous gas, is carefully collected and passed to these gas treatment units. Here the gas is separated and fed to the sulfur recovery units, where it is turned into sulfur and then sold to the fertilizer industry.
An oil refinery needs large quantities of steam for use in the refining processes and to keep pipes and equipment hot. Some steam is provided within the refining processes, but most is supplied by 3 high-pressure boilers that provide 6,000 tonnes of steam per day at a pressure of 42 times normal air pressure. All the refinery processes are linked by a network of instruments and cables to the central control room.
Data is sent back down the network to the control equipment situated around the plant. Temperature, pressure, flow and even valves at the distant storage facility in Auckland can all be adjusted at the touch of a button.
The operational team monitor and control the processes throughout the day, and as dusk falls on the refinery, a new team arrives to continue the operation through the night. And with the darkness, the night lights of the refinery create a spectacle all of their own.
Crude oil is a natural resource that comes from the ground. It contains mostly hydrogen and carbon compounds called hydrocarbons. It also contains small quantities of sulfur, nitrogen, metals and other contaminants. Oil refining is the process where crude oil and its various components are separated, converted and then purified.
Let's take a closer look at the processes by following 1 litre of crude oil from when it arrives at the refinery. The large oil tankers that bring the crude oil must meet very strict safety and environmental standards.
Oil tankers can bring up to 130,000 tonnes of crude at a time, although smaller parcels can also be delivered.
Crude comes from the Middle East, Asia, Australia, New Zealand and elsewhere. Once the ship has berthed at the refinery jetty, the crude oil is pumped ashore to the storage tanks at about 5,000 tonnes per hour.
Once we have done some preliminary testing, our oil is ready to begin its journey through the refinery.
The first stage in the process is separation, and this takes place in the distillation unit. The various components of crude oil have different boiling points. Because of this, the distiller is able to separate the crude into groups or fractions with different boiling ranges.
The crude is heated in a furnace and continually passes into the bottom of a distillation column where the gas and liquid separate. The liquid flows to the bottom of the column and the vapour rises up. The column has a number of trays that are fitted with valves that keep the liquid on the tray but allow vapours to pass through. The trays get progressively cooler the higher they are up the column.
When a vapour passes through a tray with a temperature that corresponds to its boiling point, it condenses on that tray, leaving other vapours with lower boiling points to continue on up the column.
The lightest and most volatile vapours pass from the top of the column where they're condensed into liquid. These include propane, butane and naphtha, and are called light distillates. After further processing, naphtha and butane become two of the main components of petrol. We draw various liquids off from different levels in the column. These are known as middle distillates.
Kerosene, after the removal of sulphur, becomes jet fuel. The other middle distillates are called gas oils. After the removal of sulphur, these are blended to make diesel fuel.
The remaining liquid that falls to the bottom of the column is called long residue. Our litre of oil has now been distilled into a number of separate components, all of which require some further processing.
We pump the long residue to the high vacuum distillation unit. This process is the same as normal distillation, except that the vacuum in the vessel allows the liquid to boil at a lower temperature, which prevents cracking or breaking down of the residue. Again, lighter vapours rise up the column and heavy residues drop to the bottom. A component called waxy distillate is drawn off and pumped to the hydrocracker for further processing.
Another tray allows vacuum gas oil to be drawn off and pumped to storage tanks where it is mixed with other gas oil before processing into diesel. The bottom product of this column is called short residue and undergoes further separation in the butane de-asphalting unit, where butane is added to dissolve out waxy material. The remaining material is a very thick product called asphalt, which is used to make fuel oils and bitumen for roading. The de-asphalted oil is passed to the hydrocracker unit.
Conversion or upgrading is the second stage of refining oil.
The naphtha from the distillation unit is low in octane, but is the main component for petrol.
Modern cars require petrol with high octane, so the octane is boosted by catalytic reforming, using a platinum-based catalyst and hydrogen gas at over 500 degrees Celsius.
This unit is called a platformer. We mix the low-octane naphtha from the distillation process with a stream of hydrogen gas as it enters the reactor. Here, under high temperature and pressure, the low-octane molecules are reshaped to increase their octane level and volatility. Benzene levels are also increased, and these need to be reduced before the treated components are ready to be blended with other components to make 91 or 95 octane petrol. This is done in the benzene removal unit, where a high benzene stream is treated to destroy the benzene component.
We upgrade our remaining quarter of a litre in a process called hydrocracking. In this process, the heavy oil fractions recovered from the crude are mixed with hydrogen gas and subjected to high pressure and temperature in 4 giant reactors filled with catalyst.
This catalyst helps the long chain molecules to break or crack into the smaller molecules we want: naphtha, kerosene and gas oil components. The kerosene fraction is ready to use as jet fuel. whilst the gas oils are blended to make diesel. The low-octane naphtha goes to the platformer to increase its octane before final blending into petrol.
Hydrocracking is a very complex but extremely efficient process. It allows us to get much more from the crude and to produce higher value components from more varied crudes.
The third stage of refining is the purification process. To meet quality standards and to allow long-term storage and stability, sulfur levels in the final products must be reduced. Desulfurization uses great heat and pressure to combine the sulfur atoms with hydrogen to produce hydrogen sulfide gas. This gas is then fed to the sulfur recovery units to produce pure sulfur for the fertilizer industry. We recover 2 millilitres of sulfur from our litre of oil.
While the refinery expansion was under construction, a 170-kilometre pipeline was built to Whitty in Auckland. In 2006, the pipeline delivered over 2.2 million tonnes, that's over 2.8 billion litres of petrol, jet fuel and diesel.
The amazing thing about the pipeline is that all the different products travel down the same line, yet remain separated. Petrol may be followed by diesel, which in turn is followed by jet fuel. The control system sensing equipment is so sophisticated that it can pinpoint where the various fuels are in the line.
From their screens in the control room, our operations staff can monitor where the interface between the various products is located at any point in time. When the fuel arrives at Whitty, they ensure that the fuel is switched into the correct tanks. The liquid from the interface is diverted to a special holding tank for blending later.
To handle the growth in the Auckland market, the pipeline capacity was increased during 2002 and 2005 by the addition of 2 pumping stations, one at Wellsford and the other at Kumiu. Products for the rest of New Zealand are distributed by coastal tanker or road transport.
In 2002, the government announced that from the 1st of January 2006, the levels of sulphur in diesel and benzene in petrol must reduce to bring New Zealand's fuel in line with international quality standards. The refinery's existing plant configuration was unable to meet the reduced levels. The Future Fuels project was a $180 million investment by the refinery to allow it to meet the lower fuel specifications. The project consisted of 3 new plants: a diesel hydro-desulfurization unit, a benzene removal unit and a hydrogen separation unit. Many modifications were also made to other areas of the refinery. The plant was constructed in giant modules built in Thailand. These were shipped to the refinery and lowered by crane onto the waiting foundations. Construction of the project began in October 2003 and the plant began producing the new fuels in August 2005.
Our litres journey is now complete.
From our litre of crude oil, we have produced 53 millilitres of 95 octane petrol, 276 millilitres of 91 octane petrol, 323 millilitres of diesel and gas oils, 186 millilitres of jet fuel or kerosene, 118 millilitres of bitumen and fuel oils, 2 millilitres of sulphur, and the balance of 42 millilitres is recycled as fuel for the furnaces.
And so the refinery keeps on running 24 hours a day, 7 days a week, every week of the year. Through sunny Northland days and starlit nights, the plant separates, upgrades and purifies the raw material into the fuel and products the country needs.
Marsden Point is New Zealand's only refinery. It's your refinery.